So we have to get y by itself before we can start graphing these things. First one, if you subtract your x, you have to divide by a -2 here, which flips your inequality. And I'm going to write this, since it's a line, I'm going to write it as 1/2 x minus 3. So, y-intercept is -3, slope is 1/2, so up 1 over 2. Will this one be solid or dashed? Dashed. How do you know? Right, no equal to on that one. Okay, so to decide your shading, you might be able to look at it and realize greater than would be above your line. If you aren't sure, pick any point not on the line, so 0, 0 would work again. If I do that, I get 0 is greater than 0 minus 3. So is 0 greater than -3? Yes, that's true. So 0, 0 works, so we are shading this region. Now we go to our second one. Solve for y. If you do minus your 2x, divide by -4, which flips your inequality. So how do I graph that? Y-intercept is 0, slope 1/2. I have to do a lot of points because I'm not very good at drawing straight lines up here. Solid or dashed? Okay. Can I put 0, 0 in as a test point this time? No, because it's on my line. So what do you want to try? 1, 1. And if you're not sure, 1, 1, the way mine is drawn, it's kind of hard to tell. If you're not comfortable with that, you can pick anything. If you wanted to do, 1, 5, so you were really confident that you knew exactly where it fell, that's fine. If I put that in, I get 1 is less than 1/2. Is that true or false? False. So 1, 1 did not work. That means we are shading below. So the final answer is our overlap, which is in between. We have two parallel lines. They never actually meet. What that means is any ordered pair in that yellow region would make both inequalities true. All right. Any questions about those? Let's look at a different one. Alright, are these both lines? No. The second one is. So let's start there. We're comfortable with graphing lines, we can do that first. This one we just get the y by itself. So y-intercept of 3, slope -1. Solid or dashed? Solid because of the equal to. Then shading, if you could put 0, 0 in, you get 0 is less than or equal to 3, which is true. So we are shading below this line. The other one, what's this? Parabola. Let's solve for the y. So you subtract over your x squared. This is just an upside down parabola, isn't it? We could graph it if you think about transformations. What's the plus 9 going to do to your parabola? Move it up 9, so you would have a point at 0, 0, but if you go up 9, 0, 9. Parabolas have points at 1, 1, and 2, 4. What's the negative do? Flip it. Okay, so if I took my point at 1, 1 and flipped it, it would go down to negative 1. Then if I moved it up 9, it would take me to 8. If I have my point at 2, 4 and flip it, it would go to negative 4, up 9, would take me to 5. And we know that parabolas look the same on both sides. Now, if that's confusing you because I'm trying to do transformations without actually drawing my parent function because I don't want too much on my graph, you could always just plug in some points, couldn't you? We have a general idea what it should look like. If you plug in 0, you get out 9. If you plug in 1, you get out 8. If you plug in a 2, you get out a 5. So you could go through and make a t-chart if you needed to. Or sketch the transformations and then just go back and erase your parent function so you don't have quite so much on your graph. Solid or dashed? Dash. Just like when we graph these transformations, the parabolas, I would expect a minimum of 3 exact points. Okay. Trying to decide where to shade. If we plug in 0, 0, I get 0 is greater than, not equal to, just greater than 0 plus 9. So 0 is greater than 9. Does that work? No. So 0, 0 is inside this parabola, and that doesn't work. So what you're doing is you're actually shading everything outside the parabola. So unlike with a line, it's either above or below. If you're talking about a parabola, it's either inside or outside. So this is kind of messy looking, but my overlap here is everything below this line and outside my parabola. So it's that region right there. Yeah.
Would you typically need to do points at the bottom to see how far?
If you wanted to make your graph better, yes. If we were really going to be exact about this, yes, you would. We know the parabola is just going to keep going, but you know, I don't know if my wideness is really accurate or not. So you could do more points. I will, as long as you have 3 in the right spot and general shape from there, that'll be okay for me. Okay. I'm going to give you guys one of these to try. Our parabola this time has just been moved down 4. So you should have points at 0, negative 4, 1, negative 3, 2, 0. If you wanted, if you put in a 3, you get out 5. If you want that many points, I'm asking you to do at least 3. Solid or dashed? Okay. Shading, if you plug in 0, 0, you get 0 is greater than negative 4, which is true. So 0, 0 works, so this time we're shading inside the parabola. Second one, it's just a line, y-intercept negative 2, slope 1. It is solid. If you put in 0, 0, you get 0 is less than or equal to negative 2, which is false. So you're not shading 0, 0, so you're shading below. So what's the overlap? Yeah. It's the little bottom portion of the parabola. Okay. Are those good? I'd like to do one last example, If you're okay with this, I'm done. If you're not, then we'll do another one like it. Okay, so the only difference here is I gave you multiple equations. Instead of just 2, I put 3. And I could do more than that if I wanted. So when we graph these, we just have to find the intersection of, in this case, all of them. Okay. The first one is kind of the tricky one. Do you know what that would look like? If I said x equals -4, that's a vertical line at -4. If I said x equals 0, that's a vertical line at 0. X is between them, so it's just shading in between those 2 points. If I had a y in the middle, what would it look like? 2 horizontal lines shading in between. Okay, so neither one had an equal to, so I'm doing a dashed line at -4. Dashed line at 0, shading in the middle right now. Now the rest is like we have been doing. So if you want to get y by itself, y is greater than -x plus 2. So y-intercept 2, slope -1, solid or dashed. If you put in 0, 0, you get 0 is greater than 2. True or false? False. So that means we are shading above that line. One more. Bottom one, if we solve for y, this one has a y-intercept of 10, slope of -2. Again, dashed line. I put in 0, 0. Get 0 is less than 10, which is true. So this one is shading below. Okay, can you tell with my mess up here what the overlap is? It's in between these vertical lines. But only until you get to this one, and it would stop if I extend this line. It would stop up here. It's not going to keep going forever. Okay, so I just wanted to give you an example where I put several equations together. Do we need more? So that then will be the end. Homework isn't going to be too bad. There are 4 matching problems and then 5 that ask you to graph. Since I didn't give you graphing paper for your notes, if you need a piece of graph paper for the assignment, I will give you one. I don't make that offer very often. So if you would like one, I will give you one just for today. And that is the assignment.